Hi everyone, welcome to Cola Teaches Math. I wanted to do a quick series, on tips and tricks for Unit 10, which is series and sequences. So I'm just going to go through some random things that are coming in mind when we think of series and sequences. So first thing I want to go over are the tests for convergence and divergence. So the convergence and divergence tests. I'm going to abbreviate a lot. I'm going to go through the order of tests that I would try, and we can quickly chat about all the different conditions. This is my suggestion. I would always try the nth term test first. And remember the conditions for the nth term test. We have to take the limit as n approaches infinity. And we have to make sure we don't get 0. As long as we don't get 0, we diverge by the nth term test. Next test I would try if the nth term test fails is I would go and look to see if we can do the p-series test. So p-series is really nice. It's going to look like 1 over n to the p. If p is greater than 1, we converge. If p is less than or equal to 1, we diverge. If that fails, the next test I would look to try and do is the geometric series test. This is just my opinion. And I did a video on geometric series. You can go ahead and look that up. So geometric series is going to look like the form ar to the n or ar to the n minus 1. Let's just move this down a little bit. It's kind of a little too close for comfort. And we're going to converge if the absolute value of r is less than 1. We're going to diverge if the absolute value of r is greater than or equal to 1. Next test I would try and use is, the ratio test. Kind of, you always use it. Not ration, ratio test. If you guys see in an explanation point, which is a factorial. And remember, we're taking the limit as n approaches infinity of a sub n plus 1 over a sub n. And we're going to get some value. If L is less than 1, we converge by the ratio test. L is greater than 1, we diverge. L equals 1, we're inconclusive. Then I love the LCT, the limit comparison test. So that's when you're going to choose some b sub n to compare to the original series. And to choose b sub n, you're going to choose the dominating term in the top and the bottom. And you're going to figure out what b sub n does. So you need to determine what b sub n does. If b sub n converges and the limit as n approaches infinity of the original over b sub n equals some number L, then a sub n is going to converge. And if b sub n diverges, and same thing, we take the limit as n approaches infinity of the original over the new series, and we get an answer. As long as b sub n diverges, then a sub n is going to diverge. Some teachers teach the direct comparison test. I just choose not to. We use the limit comparison test for everything, and the root test is not tested on your AP exam. And last but not least, which honestly is a last resort for me because there's just so much you have to say, it's the integral test. And you remember in prison, dogs curse. That's how you remember the condition for the integral test. Oops. It's been a long day. Curse. So the I stands for the integral test. P stands for positive. D stands for we must be decreasing in magnitude. And C stands for continuous. And the trick is that if the integral of the function converges, then the series is going to converge. And if the integral of the function diverges, then the series is going to diverge. So that's my tips and tricks for the convergence test. That's the order that I would go through and do it in. Next thing you need to remember is the whole formula for a Taylor polynomial. And a Taylor polynomial is a way to represent a function using a bunch of terms being summed up. And it's always going to be f of a plus f prime of a times x minus a, f double prime of a, x minus a squared over 2 factorial, and so forth. And if they ask for a third degree, remember that's referring to the exponent. So this polynomial that I just drew here would be a second degree because that's the highest power. You must remember Maclaurin series are just Taylor series centered at 0. Centered at a equals 0. Anytime they ask you for the value of a series, that's a dead giveaway that the series must be geometric. And you're finding the sum of the geometric series, which is a over 1 minus r. I did a whole video on Lagrange error. You're only going to use Lagrange error if it says in the question, using Lagrange error. It's kind of a dead giveaway. You're going to use alternating series error, though. A lot of the times it will say using the alternating series error. It'll kind of be a dead giveaway that you're finding the error for the alternating series because the series itself is alternating. And remember, for that one, the error is going to be less than or equal to the value of the next term. So if we use the partial sums of the first 3 terms to represent the sum of the series, or the value of the series rather, then the error is going to be less than or equal to the value of the 4th term in the series. What else? So if we find the absolute value of x minus a less than r, that's the radius of convergence. You must always test endpoints to find the interval of convergence. You must test and show the work for the endpoints. You must know the series for e to the x, sine x, and cosine x. You must have them memorized and be ready to manipulate them. For example, create series for x sine x, or cosine 2x, or e to the 3x. You must also be able to integrate the series and differentiate the series. The most recent series questions from 24 and 25 are really good. Let's see what else. Comment below if there's other things you want me to make videos on, but I'm going to do tips and tricks for all of the units.